begin with, let's start by what does that mean when I write f of 2? X is 2, and I want to find out my y value when x is 2. You agree? So I put that in. I just simply substitute that in, right? 2 squared minus 2 minus 6, and then I solve for it, right? So that's basically 4 subtract 2, 2, 2 subtract 6, negative 4, right? So that's basically it. Now, it's important that we write down that notation, because what we're going to do is we're going to now substitute in equations inside of equations. So as long as we understand the very basic of it. All right. Now, the first thing that we're going to do today is you have two equations. We are going to look at placing two equations together. Okay, so I've got f of x equals, I'm on 326 now, x plus 1. And g of x is 2x subtract 5. So I have two equations, and first thing says determine the equation of the function h of x. So I want a third equation in which I'm adding these two guys together. So I'm adding equation 1 to equation 2. So what does that mean for us? Well, the first thing I want you to do is write it out as an equation. Okay? So to do that, basically all I have to do is take x plus 1 and add it to 2x minus 5. It's pretty straightforward, right? Okay? So I've got that x plus 1 plus 2x subtract 5. Get rid of my brackets, add them together, I get 3x minus 4. So there's what h of x is. So by adding those together. Okay, so that's pretty easy, right? Now it says sketch the graphs of f of x, g of x, and h of x on the same set of coordinate axes. Okay, so this is where we get into it. I'm going to just graph it up here. It's faster. So y equals, is it x plus 1 was the first one?
Yeah.
There's x plus 1. And then I want y equals
2x minus 5.
Thank you. 2x minus 5. So there's two lines right there, right? In which they cross at what value?
6 and 7.
6 and 7. Okay. So let's just focus on that for 1 second. When I'm adding the two together, when I'm adding f of x and g of x, I'm actually adding all the y values for f of x, right, for that equation, to all of the y values in g of x. Agreed? So what is this coordinate going to be then, right here? Well, I've got 6 and 7, you said, right? Okay, so, and that's for both equations, correct? So when x is 6, y is 7 for both equations. So what is that coordinate going to become then? If I'm adding all the y values of f of x with all the y values of g of x, that's going to become what? Any idea?
And 7.
No, you got it the other way around. Because I'm adding the y values
yeah,
together, right?
6 and 14.
6 and 14. Does that make sense? Okay, so what I would do basically is, for example, right here, that coordinate is 2 and 0, right? And then if I go up from here, this coordinate is 2 and
3.
It's like 3.5 actually, right? So the coordinate, when I add these two together, is going to become 2 and 3.5. So it should go through there, right? And then I could pick any of these coordinates all the way along, and I just add their y values together. That's how it works. Or I can use my new equation to come up with the new graph. So what was the new equation for this graph?
3x minus 4.
Y equals 3x minus 4. And graph. Notice how it goes through. 2 and 3.5, like we said. And then if I go up to, does it go through 6 and 14?
Yeah.
Yeah, right there. Through 6 and 14. Okay? So there's two ways in which we can do these questions. We can write out a table of values. All right? So you would have a table of values for f of x, which would be x plus 1, and a table of values of 2x subtract 5, and then get your y value. So what we do is we go x, f of x, g of x, h of x, which would be the sum of f of x plus g of x. Okay? So just writing it out that way. All right, so maybe I go 0, 1, 2, 3. Let's just do 3. Okay, what was the equation for f of x?
X plus 1.
X plus 1. So this becomes 1, 2, 3, 4. Agreed? What was the equation for g of x?
2x minus 5.
2x minus 5. So that's going to be minus 5, right? 2 times 2 is 4, so it's going to be negative 3. Negative 1, 1. Right? So then when I add them together, I'm going to get negative 4, negative 1, negative 2, 5. That's going to be on my new graph. So there's one other way in which we can do this question. Okay? Now, a couple of the important things that we have to establish is domain and range for us. State the domain and range of h of x. Okay, well what did h of x look like?
Straight line.
Straight line. So what's the domain and range?
Elements of all reals.
They're both elements of all reals, right? Okay. Determine the values of f of x, g of x, and h of x when x is equal to 3, or negative 3. So go back to here. Okay, so let's do negative 3 now. So this was x plus 1, so that would be negative 2, right? 2 times negative 3 is negative 6, subtract 5 would be negative 11, and negative 13. Okay, so there it is there. Okay, so if you look at the bottom of the page, f of negative 3 is negative 2, g of negative 3 is negative 11, h of negative 3 is negative 13. Okay. Questions so far? You follow what's going on here? It gets easy for the adding. For sure is the easiest part. Alright? Okay. So, like adding, we have to do subtraction as well. So, same idea though. Okay, so f of x is equal to x squared. G of x is equal to
4x minus 4.
4x minus 4. H of x is f minus g of x. Okay, so algebraically speaking, I go x squared minus 4x subtract 4. Okay? Follow me so far? All it is f of x subtract g of x. Is that good? Get rid of my brackets, x squared minus 4x, add 4. So there's what h of x is. So if I'm subtracting this equation minus that equation, here's my new equation. So what type of graph did I start with? I started with a parabola, and I subtracted a line, and I ended up with another parabola again. Agreed? Okay. Bless you. So now again, they want you to generate another table in which you've got f of x, g of x, and h of x for all of your functions. But here's the one thing I want to put in here. Okay, so you could fill in the table of values, but do the same as what we just did. But I don't need to go through that again, correct? Okay, but here's the thing. for f of x equals x squared, what is the domain for it?
X is not obvious.
Okay, I want you to write that in your book, please. At the bottom there. What's your range for that graph?
Y is greater than 0.
Or equal to 0, correct? Right? What's the domain for 4x minus 4?
X is not obvious.
The range?
Y is not obvious.
Okay. So now we have to do the domain for h of x now. Okay? Which is x squared minus 4x, add 4. Now I need you to flip back to 325 for a second, because there's an important piece of information on 325. The domain of the combined function formed by the sum or difference of the two functions is the domain common to the individual functions. Alright? So the domain is common to both. Fair enough? So they both, in this case, the domain doesn't matter. X and L of all reals. Alright? So that's easy, right? If the domain of the function x is greater than or equal to 0, the domain g of x is less than or equal to 10, then the domain of f is between 0 and 10. So that's your commonality. The range of a combined function can be determined using its graph. So when we do range, so domain is the one that's important. Domain is the combination of this with this. Basically, you're taking your smallest domain, is what happens in this situation. The range for any of these, you find by regraphing this guy. So if we graph that guy,
Y is greater than 4.
I don't think it's 4.
I wouldn't.
Is it not a negative 4 there?
No, it's a positive.
Was it plus 4 in the end?
Yeah.
Okay, so what was the equation? X
X squared subtract 4x plus 4.
squared minus 4x plus 4.
Never mind.
All right. Okay. Now, you assume that because this was a 4, that was going to be your y value, right?
Yeah.
All right. But really, realistically, what does that tell you only? It only tells you what your y-intercept is, right? 0 and 4, so you know it crosses at that point. Now, I can give you the grade 11 math on it. You complete the square, right? You complete the square, and what you would end up with is actually x minus 2 squared, which is right there, which means it moves to the right too. So I don't care if you can do this part like that. You need to just be able to punch it into the calculator and do that, okay? And see it, and then do your range from that point on. You guys get that? All right, so we don't need to manipulate the math, completing the square for it. You don't have to do that, okay? All right, so there's the domain and range of sums and differences. That's the hard part. Okay, so let's take a look at work example 3, page 328. Okay, using the graphs f of x and g of x to sketch the graph of h of x. Okay, so I'm given f of x and I'm given g of x, and I want to get the combination of the two by adding them together. So solution number 1, okay, is just to add all your y values together in each individual graph. So you notice that they give you the coordinate there. So if I have minus 8, let's look at f of x right now, and let's fill in the chart for f of x. Okay, so minus 8 is what?
Negative 3.
Negative 3. Minus 4 is
0.
0. 0 is
3.
3. 4 is
6.
6. 8 is,
9.
yes, that's correct. Good. Okay, g of x. Negative 8 is
1.
1. Negative 4 is 0. 0 is
Negative 1.
negative 1. 4 is
Negative 2.
negative 2. And 8 is
3.
negative 3. Okay? And then, so how do we get h of x then? Just add those values together. I don't have them written down, so just list them for me.
Negative 2, 0. Negative
2, 4,
2,
6.
2, 4, 6.
Okay? So then you would graph that. Just graph those coordinates. In fact, you only need to graph 2 of them, right? And you would end up with your new line. Okay? All right. Okay. That's the first way to do this. All right, here's the second way. Let's determine the equation of each of those lines. So let's start with f of x. All right, what's the y-intercept for f of x? So I've got that, right? And what's the slope of it? Go from negative 4.
3 over 4.
What is it up?
Or,
Yeah, 3
yeah, 3 over 4.
Oh, 3 over 4. Okay, I see what you're saying. All right, so here it is.
Rise over.
So 3/4 x plus 3. Agreed? Okay, let's do g of x now. What's the y-intercept?
Negative 1.
Negative 1. Okay, what's the slope of that one?
Negative 1 over 4.
Got that? You guys know how to get that? Brad?
No.
Yes? Okay, so now h of x is equal to 3/4 x plus 3, add negative 1/4 x minus 1. Which gives me 1/2 x
Plus 2.
plus 2. There's the equation of h of x. Did your graph cross 0 and 2?
No.
Yeah? And the slope was 1 over 2. Okay, so far? Yeah?
Yeah.
Alright, it's not. The adding and subtracting isn't tough. Okay, it's not the part that's going to be difficult to do. Alright, so let's go to products now. So products and quotients. So we've done the add and subtract of putting 2 equations together. Now we're going to do the multiply and dividing 2 equations to put them together. Okay, take a look at the bottom of 335. The domain of a product or quotient of functions is the domain common to the original functions. So the same idea. The domain of a quotient of the function must have the restriction that the divisor cannot equal 0. That is for h of x, where f of x over g of x. The values of x are such that g of x cannot equal 0. So you have non-permissibles for g of x in that question because it's a quotient. Does that make sense? So you find out what those are. The range of a combined function can also be determined by just graphing it. Okay? So let's look at the notations and everything that we need to know. So I have f of x equals x minus 3. What does g of x equal?
X squared minus 8x plus 15.
I have that. Okay? So the correct notation, the way they write it, is h of x is equal to f dot g x. Now, there is, when we get into composition of functions, they've got something similar to this, so we have to know the difference between the two, but for right now, this is how they write it. So the dot, of course, is just multiply. So f times g of x. So we want to determine it. So what do I need to do now? Well, x minus 3 times x squared minus 8x add 15. Okay, so here's your grade 10 math right now. How do I multiply a binomial by a trinomial?
Which one through?
Trinomial. Both terms all the way through the trinomial.
Yeah, okay, that's the simplest. The other way would be to stack it, right? You guys remember how to stack it? You guys like that? Okay, so let's multiply x through here. What do I get?
X cubed subtract 8x squared plus 15x.
Multiply the negative 3 through.
Negative 3x squared, positive 24x, and then negative 45.
Good. Combine all your like terms. There you have it. So I multiplied a line by a parabola and ended up with what?
A quadratic function.
Cubic function.
Same thing.
Cubic function, right? Same thing, not quite. All right. So now, state the domain and range of h and k. Okay. Or of h of x, sorry. All right, so what's the domain for this guy right here?
X is an element of all reals.
Okay? And what's the domain for this guy right here?
Same thing.
Same thing. So therefore, my domain for that graph is x and element of all reals because they have the same x and element of all reals. What's the range for this graph now? So now, I want you to think this through. What was the range for this guy?
X is an element of all reals.
No, range.
Y is an element of all reals.
Y is an element of all reals. What's the range for that guy?
So y is,
You can't tell, right? Not in the,
Yeah.
not in the form that it's in right now. But it'd be y is greater than or equal to something, right? Okay? But because I went from a linear to a quadratic and multiplied them and got a cubic, what's the range of a cubic function?
Y is an
an
element of all
element of all reals.
Okay? So there's your solution. You're done, all right? Make that one. Okay, so let f of x equals x subtract 3 and g of x is equal to x squared minus 8x plus 15. All right, and we want the quotient of these two. Okay, so this is where we got some work to do. F of x is equal to what?
X minus
G of x is equal to?
x squared subtract 8x plus 15.
Okay, and I want h of x to be that. Okay, so we just finished doing this. So we have to go through the same steps and procedures that we just did, right? So we have a possibility of a point of discontinuity, right? And we have asymptotes here because of a quotient. So I've got x minus 3 on top. That's going on the bottom, so can that be factored?
X minus 3, x minus 5.
X minus 3, x minus 5. Okay, so what am I looking at here then?
Point of discontinuity.
Point of discontinuity at
X equals 3.
x equals 3,
X equals 5.
and x can equal
5 given asymptote.
3 and 5, so x minus 5, well, we'll get to that in a second. So now, cancel that, what am I left with? 1 over x minus 5. Okay, what's the domain for that graph?
X is less than 3, x is greater than 5. Multiply 15.
Okay, let's start from scratch here on the graphing part, okay? Oops. Okay, what does that graph look like? Well, It's your 1 over x graph, right? Moved which direction?
5 to the right.
So I have that. This, and what else do I need to add in there?
One is continuity.
Add
3.
that right there. Okay. So what's the domain for this graph then?
X is an element of all reals, but X can't equal 5. Or, yeah.
X can't equal 3 or 5, correct?
Yeah.
Okay. What's the range for this graph?
That's an element of all reals.
Y
But
can't
y
equal
equals 0.
Why what?
Y
And
can't
equals
equal
0.
0.
Is that it?
Yeah.
No. From that point at discontinuity,
So
right?
then we'd have to find.
Yeah, what the y value is at that point. Okay, so we substitute in 3 into here for x. So I get 1 over so negative 1/2, right? Y can't equal 0 or negative 1/2. So you have to remember that. So that's new. We haven't done that before.
What if I just put it in my calculator, like second function calc? Or that would be in the decimal.
That's fine.
Okay.
Yeah. But okay, let's do that because I think you're gonna get an error, to be honest with you. So put in 1 over x minus 5.
No, you got a negative 1.5.
And you went x equals 3 and you got an answer? Okay. I didn't think it would give you a solution for it.
Yeah, give me.
Give you-
Because we don't have the.
We don't.
I don't think it puts the point of discontinuity into the graph.
I think
Okay, let's do this. Let's do this then. Let's graph x minus 3 over x minus 3 times x minus 5. Put the bottom in brackets. Top and bottom in brackets. Okay, so let's graph this right here. This guy right here. And then try it. I bet you it changes it.
Yeah, you don't get it.
You don't get it there, right?
It goes, but it doesn't give you a number.
Yeah.
Why?
It's just
When.
So, okay, so that's actually kind of neat to know that if you just graph what you've got there, you're not going to get that point of discontinuity. You have to graph the original equation in order to get it. All right, so just remember that when you're doing this. Okay? Any questions about that so far? There's a lot here. I know I'm going through it. You're going to get the next 3 to 4 days here to do this. And again, I'm not going through the word problems yet. Anything yet so far, guys? No? Okay. I'm going to show you that 10.3 right now. And then that's it. And then you can go back this week with Ms. Ludwig and she'll go through this each day with you and answer questions. You're just familiar to all this? Okay. All right, here's the last one here, guys. F of x equals, turn to page 346, please. 4 minus x. What's g of x equal?
X squared plus x.
X squared plus x? Okay. Now, this is what we call composition of functions. All right, so we did an example already where I did f of 2 and then you just substituted 2 in for your x values, right? Well, what I want to do now is I'm going to combine some of these functions together. Like this. Okay? So, number one rule about this is work from the inside out. Basically is what that means. Alright? So what I'm doing here is to solve this now. To get this guy, I'm going to put 2 in for all my x values and my g of x and get a number. Okay, so I'm gonna go g of 2 equals 2 squared plus 2, which is equal to 6, correct? So now, this becomes f of 6. And now I put 6 in for that, which is, oops, 4 minus 6, which is equal to negative 2. Okay, so you work from inside the brackets out. Does that make sense?
Yeah.
Okay, let's do it the other way. Let's go g of f of 2. How does that change things?
You're then
And leave it at 6.
What's happening?
the final answer is 6.
Yeah.
Okay, so you got that by going f of 2, which is 4 minus 2, which is negative 2. Right?
No, it's positive.
It's regular 2.
Oh, plus 2. Plus 2. So now I go g of 2, which is equal to 2 squared plus 2, which is equal to 6. So that's called composition of functions. So far, so good? Okay? Again, work from the inside out. Where does this become a little more complicated? Well, what if I do this? Let's go f of x equals 4 minus x. Oops. G of x equals x squared. Is it plus x?
Yeah.
Plus x. Okay. So now, what if I do this? Okay. So now I don't have a value to put in. So what am I doing? Well, I'm taking my g of x equation, which is what?
X plus X. X squared.
X squared plus x. And then what do you think I'm doing with it?
4
Putting it
subtract
through
that.
Value.
Right? So it allows us to combine functions together. So far, so good. Does that make sense? Because we're going to get a little more complicated here. We okay? All right. Let's look at, let's go back again. I want to do this one more time. I want you to look at the bottom of the page at 345. Again, this is important. And that is the domain of f of g of x is the set of all values of x in the domain of g for which g of x is the domain of f. Restrictions must be considered. Okay, so we have to consider the first function and the domain of it before we put it into the second equation and get it out. So we're going to go through an example and talk about this. So example 2 does work with this. F of x is equal to
X minus 3.
x minus 3, and then g of x is equal to square root of x, right?
Yeah.
Okay, so the first thing I want you to do is and this is what I said, the notation looks similar. Open dot, that, okay? Which means then I want to put, this means put g of x, this is the same as this here. Okay? Oops. Drag. That's the same thing. That's what that notation means. Casey, you see this?
Yep.
Okay. So now, I'm going to put that in, basically for my f of x equation. So what does it become? Square root x, subtract 3. Agreed? Yeah? All right. What's the domain for the first guy?
This is not on the variables.
Domain here,
X is greater than 0. 3.
x is greater than or equal to 0, agreed? Okay, so now, again, I'm gonna do my domain of this guy right here. What is the domain of that guy?
Put it in B. X is greater than or equal to -3.
Okay, which direction does this guy move? No, not -3, no, sorry, no it isn't. No, let's do that again. Which way does that guy move?
It's to the right.
Does it?
Yeah. Maybe.
Okay, hold on, let's come back to that, okay? Let's do this. G of f, okay? So I'm gonna put my f of x into my g of x, right? What is that gonna give me?
Square root of x is 3.
Okay? What's the domain of that? Well, x in the law of reals, right? The domain of this still is x is greater than or equal to 0, but what's the difference between those two? Which way does that move and which way does that move?
First one moves down, the second one moves
Second one moves
right.
right. Okay, so what is the domain for this guy?
X is greater than or equal to 0.
Still that, correct? And what's the domain for this guy?
X is greater than or equal to 3.
Does that make sense?
I don't understand how you extending the square root changes the direction.
Perfect. What's my original? That, right?
Yeah.
Which is that?
Yeah.
Agreed?
Yeah.
Okay. Now remember what we've done so far, Casey.
Okay.
For every single one of our questions, or equations, that's how we've set it up, right?
Yeah.
So then, what does H do to your graph?
Moves it up and down.
No.
Or left and right,
Left and right, and K moves it.
up and down.
So does that make sense why that moves
Yeah.
the way it does then? So then my K value is -3.
Yeah.
My H value is 3.
Yep.
Fair enough? Okay, that's enough to start you guys. Okay? It's gonna get a lot more complicated than that, especially on the domain and range of these graphs. I'll look at one more example, 349. Let's look at example 4. And that is, you have to, and I actually think this is kind of fun to do, but you have to create two equations that give me this. Create two equations and then write out the composition statement for h of x here. So what could be two of the equations that you would use?
F of x equals 3x minus 2.
F of x equals 3x minus 2.
G of x equals square root x.
G of x equals square root x. H of x is found by going
G open circle F.
So you're taking this function and putting it into that function. You guys agree?
Yep.
Brett, that was pretty fast, right? You understand what he was doing?
Yeah.
Okay, so he used the square root function,
Mhm.
and he used 3x minus 2 as a separate function. And then plug this into here to get that. Okay?
Okay.
Alright. And that's 349, but I think that you'll be fine on that. Okay, so there's lots there. You've got 4 days to do it, the rest of today and then until Friday. To get that done, we'll do on Tuesday next week.
Can I have an assignment?
Yeah, why are you so late today? And not phoning in.
Slept in.
couldn't phone in. Phone doesn't work.